Okay, so today guys we're going to learn about how to multiply complex numbers together. So from the previous video, you know that an imaginary number will take the form of a plus bi or x plus yj. And here, in our first case for z1, our x is 1 and our y is 1, and for z2, our x is 1 and our y is 2. So from this, what we have is we want to understand what multiplication between these two things are, and what does that mean, and what does this new vector give us. So if we do z2 times z1, which would be the same as z1 times z2, we get 1 plus I times 1 plus 2i, which let's say is equal to z3, and from that we'll get that that's equal to negative 1 plus 3i. And I'm going to show you how we get this. So if we say that because I is equal to the square root of negative 1, so if you square both sides, then that means that I squared is equal to negative 1. So if you factor this out, like if you did with polynomials, for example, you get 1 plus 2i squared plus 3i. But we know that I squared is negative 2, so that would be 2 times negative 1, which will make that now negative. And then we get down to negative 1 plus 3i. So what happens here? So if we look at our graph, if we graph z1 and z2, they're both in the first quadrant of our graph. And by multiplying these together, not only did we, and it's key to note that these are both positive, but in the overall theme of it, it's important to know that when we multiplied these two vectors together, the resulting vector caused rotation. So as you can see that the first vectors, the first two vectors, they're in R1, but when we multiplied them together, we rotated it in the plane and we made it bigger. And that's going to be determined on both the coefficients on these guys, and if it's negative and positive and whatever. But it's important to know that when you multiply complex numbers together, you're actually rotating. The result is it results in a rotation of the new vector. So if you had like two vectors like this that are in R1, what happens when you multiply them together, the result is you get a vector from this example that is not only bigger in terms of magnitude, but it's also in another quadrant, so it rotated from the first quadrant to the second quadrant. So that will be the end of this video for complex multiplication.